complete square. We did some graphing as well.
Okay, so we did graphing of quadratic last time, right? Did we actually get through the problem?
I think we did.
There were no x-intercepts. Remember that? It was tangent to the x-axis. There was a double root. I'm gonna give you a little heads up. Okay, you can relay this to Kate if you want because she's not here to be nice because that's this tomorrow. You would definitely have graphs. I'll tell you the graphs you'll have now, not the equations, but I'll tell you the types. You have a quadratic for sure. Okay, absolutely you have a quadratic. You will have a rational function for sure. Rational function for sure. Now, mind you, you can use your graphing calculators. So you can always check what these look like when you have to show work. A graph without work receives no points. None, literally. You get nothing if you don't show work. So I need to see how you get the values you get. So you have quadratic, rational function, and then, if you recall, we didn't do a lot with this, but we did enough that it's on the test. I'm trying to think, maybe I'll do an example of it today actually. Polynomial functions with end behavior. Remember how the graphs, if it's x to the fifth, either they look like this or they look like this. X to the fourth either opens up or they both open down. We talked about the degree of the polynomial following the behavior of parabolas or linear functions. So if you have something like x to the third and you have to graph it, the graph's either going to look like this or like this. Either it's going to rise or it's going to fall like a linear function. So let's do an example of one of those to start.
When do we have to prove the analysis?
That's a good question. I usually accept it on the day of the final in case you want to study, but if you want to turn it in today, you can too. It's up to you. Yeah, textbook. Okay. At the end of class or during the day, come by and drop it off. Thank you for the question. Second thing I should mention also in addition to that, you have a summer math assignment. You know that, right? Okay. So you're going to look and you're going to see advancing to, and you pick the course you're advancing to, which is going to be honors geometry next year. Okay. The two of you are sophomores, so you have to figure out the one you're going to be doing because you're not going to geometry next year. You'll be juniors next year. But for the others that are freshmen, that'll be sophomores next year, it'll say advancing to honors geometry. That's the summer course you're going to do. If for some reason at the end of this year we decide, and you decide, or you talk to your parents that you're not going to be in honors next year, and you want to maybe transfer into the regular section, please make sure you don't do both. You don't have to do both assignments. So make sure you do the assignment that correlates to you. So if you're in honors math next year, you advance to honors geometry. If you're not going to be in honors math next year, you look for the regular geometry. Depends on what you're going to be in next year. Okay, you'll know that if like we talked about this already, if you have lower than 85 at the end of the year, then it's like a question. If it's lower than 80 at the end of the year, you're definitely not going to be in honors next year. If it's above an 85, you're pretty much guaranteed to be in honors unless you find that you don't want to and it's been so overwhelming that it's going to be tough to keep up with. But for the most part, 85 is like that cutoff where it's like a definite and then it's a maybe below. 85 is the threshold.
For the textbook, where can I find you tomorrow morning?
So I'm going to be tomorrow you have all your proctors will be in each room. I'm the assistant proctor for the relief. So I'll be in the math office the entire time while you're taking the math exam. So you can drop it off right before the exam, right after the exam. If I'm not there though, make sure your name is on the inside cover.
Right.
I have the numbers. The number has to correspond to the book you gave me.
Okay.
So if you give me a book that's not your number from the beginning of the year, and somehow you got a book lost, then you're going to have to pay for it. Okay, so please make sure you give me your book that you took at the start of the year. Your name should be in it because I told you to put your name in it at the start of the year. Okay, any questions about textbooks? If for some reason you lost it, it's not a big deal. Go to Amazon, buy one, buy like a used one, something that's decent. These are only like $40, $50. They're not expensive. Okay, but if you lost it, make sure to do that and turn it in the summer at some point.
When you're looking at averages, you look at the weighted average or the unweighted average?
The weighted average, yeah. So the weighted semester average for each one and two, average those values together gives you your overall grade for the year. Okay? So let's look at a polynomial graph here. So we're really in chapter 8. Okay, we did this with chapter 8 with rational root theorem. Get an example that I know will work nicely. Yeah, this is a great one. Okay. So let's say we've got x cubed, so f of x equals x cubed plus x plus 10. Okay? That's what we're getting to start this problem. Now, if you're asked to graph this, obviously you can check right away on the calculator what it looks like, so it's really nice to know that, right? On the test, you can use your calculator for this year. So you can see where the roots are on the calculator, God bless you, see where the roots are, and then use your synthetic table to test the roots. If you couldn't, for some reason, use your calculator, even though you guys can, you would use rational root theorem and Descartes' rule of signs to figure out what to search for. We got the whole process in this class. The other class, I don't think did as much of that. That's why we're having calculator lab for this. Yes?
Just like if you have to like go into searching for the roots, even if you find them already on your own.
You need to prove it on the test. So you can't just say like 5 is a root because I saw it in the calculator. If 5 is a root, what would prove that? How would you prove that 5 is a root?
The rule of signs, and then you factor out each.
And what would the remainder be? 0. That's all you got to do. No need for signs, no need for factoring, going through all that process. Just go to the synthetic table right away and put the number on the outside, whatever it is, and show that you get 0 as a remainder. Okay? Once you do that, then you'll get a subtable or a sub-equation which you can then factor. Okay? If factored. Look at your calculator. Anybody idea what it is? What it is? What is it?
Well, I was just going to say, like, with the P and Q values, and there's, like, no sign changes, it's, there's going to be, like, only, like, one negative root. Or, yeah, one negative root.
Why one negative root? There's no sign changes for the positive, so what does that tell you?
So that tells you that either there's, that doesn't cross the the y-axis.
If you have no sign changes, it means that there's no positive roots. That's all it means. That's what I asked. What were you talking about crossing the y-axis and stuff?
I don't know.
So if there's no sign changes in the original, right? That's the original.
Yeah.
That means that there's going to be no positive roots possible. Now remember that we're missing a term here. We're missing a 0. We're missing the x squared term. Okay, that's what we're missing in this part. That makes it better, right? We're missing the x squared term here. So if there's no positive roots, we'd go right to the negative roots. But again, guys, on the test, if you're given a calculator, use it to figure out what the root is by looking. By looking. Anyone look at it? What's the root for this one? Negative 2. Okay, let's test it to prove that it's true. And I guarantee you, I will give you problems that have missing terms. You have to remember the 0 placeholder. X squared is missing here, so there's a 0 placeholder there. Bring down the 1. Negative 2 times 1 is negative 2. Negative 2 and 0 is negative 2. Negative 2 times negative 2 is 4. I take that 4, I add the 1 to it, I get 5. Negative 2 and 5 is negative 10. Negative 10 and 10 is indeed 0. So this must be a root. Okay, it must be a root because the 0 remainder. Now, going back, Tristan talked about factors before. What else could you tell me? If negative 2 is a root, if negative 2 is a root, then
the remainder in the synthetic table is the depressed equation.
good. What else? What else? Use the negative 2 or use more of that. X plus 2 is a factor. Again, if negative 2 is a root, x plus 2 must be a factor. That's one of our factors. Even though this doesn't ask us for factors, you might be given a problem on the test where you have to factor something that's a polynomial. And maybe you're started by giving one of the factors. If one of the factors of this polynomial is x plus 1, determine the other factors. So if x plus 1 is a factor, what should you test right away? Negative 1. Why do you do that? So that the next line is the depressed equation. Even if you know it's a root, still test it. So that now you can say the following. There's my depressed equation. Can this be factored? Can this be factored? Anything that multiplies to 5 and gives you negative 2? No. So what method do we use? Or? Yeah, but quadratic formula works, right? I think that'd be the easier one. Completing the square is actually pretty easy also too, right? I'll do completing the square. You guys do quadratic formula. Who won? Did I beat you? It was a race. I'm kidding. It depends on the problem. I saw this as an easy completing the square problem because the linear term here, because b was even. That's the reason I did it that way. Okay, but if you do this with the quadratic formula, when you simplify, you should get the same answers. 1 plus or minus 2i. Okay, 1 plus or minus 2i. What does that tell me? What does that tell me? Remember, I'm trying to graph this, right? I'm trying to graph this.
That it can only be graphed, the two of the roots can only be graphed from the imaginary plane, so you're going to have one constant next time.
Very good, George. You will only have one real x-intercept here. So if I'm thinking about the graph now, I know at -2 there's an x-intercept. I know the y-intercept was 10. So all I've got is that. That's really all I have. Okay, I know that because this is cubic, it follows the trends of linear functions. If it's to the 5th degree, it follows trends of linear functions. Linear functions that are positive rise. That's what's going to happen here. The positive leading coefficient of x cubed means, look, you got to focus, man. Come on, it's the last thing. Don't be doing all this stuff. It means that this graph is going to rise. It's not going to fall. So we know at least the general trend. You can kind of see it also here, right? If that's all you're given and that's all you can get, then here I would recommend choosing a couple extra points to maybe help you with the curvature. What does this look like? Anyone have the calculator graphed already for this? Hannah, what does it look like? Is it actually?
It just looks like that, and then down.
That's it.
Yeah.
Can you zoom up a little bit? Hit window and hit Y max of 30 instead. I think it's going to start to curl back. And then you graph. Window, Y max 30, graph. So if you take a look at this graph beyond 10, right? This is 10 right here. This graph comes up like this, and then it actually curls further. Okay, so a couple points might be useful. Now, on the test, you can almost guarantee that you have 3 real roots. Okay, you have 3 real roots. Maybe they're not going to be imaginary, but they might be irrational and real. So I could get an answer, like let's say hypothetically, I wish I had one I knew right away. Let me see if I can find one that works.
So it's not like it'll be imaginary.
Imaginary roots are useful to know where they are, but for something that's cubic, you probably want 3 roots so you can get a better shape of the graph. I'm going to guess it is. I made this exam, this is the 5th year here now, and I haven't changed it since 4 years ago, your final exam. It's the same material taught every year, so the final hasn't changed. So I'm not 100% sure if the example with cubic has 3 real roots, but I'm saying that you probably want to, I'd almost guess that it does have 3 real roots. Yeah?
I know I've gone over this a couple times already, but could you go over again how you change x squared minus 6 plus 1 to x minus 1 squared over
Yeah. So what I did was I moved the 5 over first as a -5. Right? Because this is really equals 0. I didn't put equals 0, sorry. Okay? I move the 5 over. Then I say half of this is square it, which goes here and here. Now this will always factor into half of this right here. Always. Always. And if you don't believe me, this is just x minus 1, x minus 1. Right? If I factor this, it's x minus 1, which gives me this. And then here I have the -5 and 1 yields -4. Get rid of the square by square rooting, plus or minus. Square root of -4 is 2i, and I move the 1 over as positive. Okay? I'm trying to find one that will guarantee work. Here, how about this one? How about this one? Oh, that should be a 2x to the 4th, sorry. The first term should be 2x to the 4th. Now, for a problem like this, it's a little bit tougher because of the fact that it's the fourth degree. But because you have your calculator, you can do this also. This, since it's an even degree, follows what trend? Follows what other graph? What does it look like?
Yeah, it's like a problem.
Very good.
It's up or down.
It's either going to open both up or open both down. One or the other. Linear functions either rise or fall. Cubic or rise or fall. Fifth degree rise or fall. These either open up or open down. Now, with a fourth degree, it could have some funky looking stuff going on in the middle, but we'll get to that point. If you go to your calculator, you'll see right away that it looks like -3 works. Oh, this is going to be imaginary too. I thought these were real. Jesus. It looks like -3 would work here. If I try -3, I'll get a depressed equation. From that depressed equation, I get another equation. And then 3/2 will work. This is not helping me too much. -3 is back here. 3/2 is right here. This graph will probably look something like this. -9 is down here, and then it'll come back up like that. It only has 2 real roots. The other 2 are imaginary. What I'm saying is the more real roots you have, the easier it is to draw the graph. Okay? So if you had a cubic, I'm not even going to come up with the equation this time. Let's say that the cubic itself, instead of giving you an equation, let's just say that the roots of the cubic, so a new problem, the roots of the cubic were 1, 3, and 8. And it has a negative leading coefficient. Okay, it has a negative leading coefficient, and the roots are 1, 3, and 8. I start by graphing my roots. Okay, there's my 3 roots right there. If the leading coefficient is negative, what do I know?
That it falls.
The graph falls. Just like a linear function with a negative slope. The leading coefficient, what does the leading coefficient mean again? What is that phrase, leading coefficient?
It's like the number in front of the x goes to the highest degree.
Yes, very good. The x of highest degree, the coefficient of that, the number in front of it. So this might be something like -2x cubed plus ... whatever. Okay? So as a result, it's going to fall. So I can do this. Everybody, I can do this right away. Boom. I know that. Automatically it can happen. Automatically I can do that. Now, in between there, it's a question of what happens. This graph would probably dip, rise back up, and go back down. And there's my cubic function. Okay, again, because you have a calculator, you can obviously check almost all of these. You can check almost all of these. How about sum and... Yeah.
Just gonna ask for y equals. When you get the quadratic for that function, could you find the axis of symmetry by using negative?
It's not quadratic, though. It's
Well,
a
I
cube.
know when you get a depressed equation from 3 1/2.
You would get a quadratic, but that is not the quadratic you're graphing. You're graphing the fourth degree. So the axis of that quadratic won't help you for this graph. Remember, this graph is of the original. When you get a second depressed equation, it's a whole new function. Its roots are useful, and we've seen that. That's why we get the roots of it. But the actual axis and the y-intercept of that second depressed equation, it has no significance on our graph. Good question.
You don't have to focus about the curvature.
Yeah. But if you have a graphing calculator, you could probably just trace and figure out this little mean, this little max, and plot those two. Think about it, right? You can find a lot of points. Use your table feature and get a bunch of points to help you graph it. But the idea is you want to get the roots out and really graph the start. And then you have the y-intercept, and you have the end behavior knowing that it looks like that. Okay? How about sum and product of roots? Who remembers that? Sum and product. Yeah, what is it? Very good. Is it, there, is one of them negative? Why do I feel like one of them is negative?
Yeah.
B over A is negative, right? Okay. I think you said B over A. So this is the sum and product of roots formula. What are A, B, and C here? What are A, B, and C? You gotta know what the variables are, right? To use it.
The standard form
Of a,
equation.
what kind?
Quadratic.
Good. So those come from the coefficients, right? So if you have a problem and you're told that the sum of the roots is 5 and the product is, I guess I can pick anything, right? Yeah. And the product is -7. Okay, the sum is 5 and the product is -7. Now, you know nothing about the roots, but you know the sum and the product of the values of them. Can you come up with the original equation as a result? So to do this, we want to think about the fact that, you know what? The sum is really -b over a, and the product is c over a. So what I can recognize here is I could say to myself, since there's no fractions involved, what should I make a automatically? What should I make a automatically if there's no fractional parts involved? Make it a 1, because anything over 1 is not a fraction, right? So let a equal 1 to start. If a is 1, then c is just what? Very good, Bridge. If a is 1, b is what? -5. Okay, so b and c are -5 and -7 respectively, and a is 1. So this would just be, okay? That's all it is. That's all it is. Now, again, are these roots real? Are they imaginary? I don't know. I have no idea. But if I did find the roots and I added them together, I'll get back to 5. If I found the roots and I multiplied them, I'll get back to -7. If given an original function and you're asked to do that, you can do it the same way. So if you're given something like this, and you want to find the sum and product of roots, just literally use the values. The sum of roots is -b over a. That's going to be -6 over 2, that's -3. The product of roots is c over a. That's going to be -4. You've got it already. You've got it already. There might be a problem that says, prove that the roots are the following. Prove that this is correct by using sum and product of roots. Using sum and product of roots. Okay, so maybe you have to do that when you're thinking about finding the roots first and then proving it true afterward. So for example, with that one, you'd have, I'll make it easy. What does this factor into?
X plus 4 plus 1.
Good. So what are the roots?
-4 and -1.
So the sum of those, what's the sum of those two values right there? And the product is? Oh, take a look. It works out nicely. Product is defined as c over a. A is 1 here. This is really c over a, which is 4 over 1 from the equation up top. And the sum of roots is always -b over a. Well, that would just be -5 from up top over 1. So you can actually prove that these are correct by summing them together, by multiplying them, and then checking with your rule to see if you got the right answers. I'm trying to think of stuff that you haven't asked, right, in the last couple of days. You guys have asked a lot of good... Yeah, George, go for it.
Do you know if there's like any topic that I haven't gone over yet that's like a major portion of it?
Every topic is amazing. If we haven't gone over direct and indirect variation, we can start that one. Let's do that. Direct and indirect variation. So if two things are directly related, how do I write the general equation to start? Just the general equation.
Y equals cat.
Good. If two things are indirectly related, what do I write? Indirectly related. Okay? Now, if it's both, for example, I'll give you a little physics example, which I gave you on the test. I said at one point, I think I remember, I said that the gravitational pull is directly related to the mass, but indirectly related to the distance. You'd say the force of gravity is directly related to the mass, but indirectly related to the distance. It would look like that. Directly related shows up in the numerator, indirectly shows up in the denominator, and you'd be given a scenario. If the force is this, or the given mass is distance, figure out another scenario. These problems are where you find K first, and then go back in through. Make sure you have batteries tomorrow. Make sure that your calculators don't have any programs in there written. The juniors think it's convenient to write like notes in their calculator, which they do. They're going to be clear on the test. Okay, we're going to make sure to do that. Make sure that you have a pencil. You can use a pen on other stuff, but there is a Scantron portion. Bring a pencil.
Wait, that is yours.
Or you also have a quadratic on your calculator, like a quadratic, like,
You really shouldn't. If you want to use it to check, because you have to go up the calculator right, it's fine. But if they come in and clear it, it's just going to go away. Which I think is going to happen anyway. So I don't think it's going to happen.
So every time
You should sort of variable things. So if I hit A and hit enter, it's 0 because nothing will stop. If I hit X, go down here and enter, it's sort of 10. This X is just a fold for 10. Don't worry about it, it doesn't matter. What you can do is you can clear a little value, but it does nothing. It's not going to hurt you at all. So if you want to go like this, I'd say here. Now for X. Hey, you want the last couple? Yeah, there you go.
I'll take the last one.
All right. See you, Annette. Have a good day.